Hi everyone, it's Sorkin. Today we are going to solve LeetCode 513 find bottom left tree value problem. So let's first take a look at the problem. We are given a root of a binary tree and we need to return the leftmost value in the last row of a tree. So what's that mean? So for example, in this example, we need to return 1 because it's the leftmost value in the last row. So we have only two rows, 1 and the 2, and the leftmost value is 1. How about this example? In this example, we have 4 rows, 1, 2, 3, and 4. And the leftmost value, since 4 doesn't have any value, is 7. So we are returning 7 as a result. So 7 we are returning as a result. So how we're going to solve this problem? So the obvious way that how we can do that is we can breadth-first search our tree, and so once we go to the every layer, so for example, let's say that we are on the first layer, the first element that we visit is 1. In the second layer, the first element that we visit, so actually in breadth-first search, the first element that we visit in the next layer or the level is the leftmost element, so leftmost node. So and we are taking that value. So if we are going to breadth-first search, and once we go to the next layer, we just take the value of the first node that we visited, and at the end we are returning the value of that node. Okay. So first thing that we are going to do, we are going to create a queue that we are using in order to breadth-first search our tree. So for that, we are going to create a linked list, right? So next one is that we are adding our root. We are adding our root to our queue. Now we are BFSing our tree. But before BFSing our tree, let's create one variable. Let's just call it a result, to which we will assign the first value of each level. So let's just set the value to 0, and we are going to return the result. Okay. And now we can start to BFS our tree. So to do that, we are until our queue is empty. We are BFSing our tree. We are going to each layer and taking the first value and setting that to the result. In this case, we need to get the size of the queue. So let's just call it a size, and for the queue, get the size. Okay. Okay, now we can check that layer. So for int I is equals to 0, I is less than size, and we increment I. So if I is equals to 0, then we are updating our result. So for the result, we are adding a node value, right? Because if the I is equals to 0, which means that it's the leftmost element, so which means that it's the first element in that layer, in that row. So we are adding that, we are setting that to our result. If we have, let's say that a 5 layer, the result would be the leftmost element of the 5th layer. So we are setting that the previous 4 layers values will be overridden. And after that, we are checking that if our let's take our tree node here, our current node, tree node, let's just call it a node, and we are pulling that from the queue. And we are checking if the node left is, if there is a left child, then we are adding that to the queue. If that not equals to null, then what we do, we are adding queue, we are adding our leftmost, our left child. So we are adding left. And the same we do, we can actually copy paste this part. So the same we do for the right. The same we do for the right. That's it. Let's check this. Okay, we need to parameterize our queue. We are adding here 3 node. Let's run it one more time. Okay, it works as expected. Let's calculate the time and space complexity of our solution. What's the time complexity? Time complexity in our case is of n, because worst case scenario, we are going to add in, we are going to visit all the nodes in our binary tree. The space complexity is also of n, because the space complexity is determined by the size of our queue. The size of our queue, in the worst case, we in the bottom layer, in the lowest layer of our tree, we are going to add n divided by 2 nodes to our binary tree. So for example, let's say that we have a balanced binary tree of 7 nodes. In the first layer, we are going to have 1. On the second layer, we are going to have 2. On the last layer, we are going to have 4 nodes. So our space complexity is all n divided by 2. We can ignore the constant part. So it's of n for both. Okay, let's go over our solution one more time. The problem is that we need to find the leftmost value of the node. To do that, we are breadth-first searching our tree, and we are adding to our, we are creating a variable result to where we are setting the first value on each layer. So for example, if the I is equals to 0 in this case, we are adding the value of that node to the result. So that way we make sure that the lowest layer, so we have the leftmost value of the lowest layer in our binary tree. And we are breadth-first searching here, and at the end we are returning the result. Okay, I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.